This is your class lesson for section 3.1, part 1, functions and function notation. In number 1, we want to decide whether each relation defines a function. So what we talked about was looking at the x values. We cannot have any repeated x values because if we have a repeated x value and they have different y values, then the relation is not a function. But as you can see here, all of our x values are different. So yes, this is a function. Let's look at the n, set n. We have 2, 3, 4, and 5. So again, this relation defines a function. Let's go ahead and take a look at set P. -4, 0, 2. Oh, well, -4 is repeated. Now, let's look at their y values. -4, 3, and -4, -3. You can only have one y value that corresponds to that x value. So you can't have -4, 3, and then also have the y value for -4 be -3. So this relation does not represent a function. Okay, let's talk about the domain and range in number 2. So the domain in A, set A, and I'm going to put set A to the right here, or the set in A. And for the domain, we're just going to list these x values, -7, 7, and 1. We will not repeat this 7. We do not repeat things in a set, members of a set. Our range is 2, 0, we're not going to repeat 2, and 5. What do you notice? We have two x coordinates that are the same. Both of them are 7. One has 0 and one has 5 as the y value. So this does not represent a function. This is just a relation. Okay? Let's go ahead and look at B. Let's get our domain and range down. Our domain is 1, 2, and 3. Our range is 4, 5, 6, and 7. We don't see any issues yet, except when we go to see if this relation represents a function, we have the point 2, 6, or 2, 5. And we also have 2, 6. So that rules out we do not have a function. These x values are repeated. Okay? And you could write the other points as if you want. 1, 4, and 3, 7. Okay? Now, C is a very interesting problem because at first you might think, oh, this is not a function. But look, all of the x values are different, okay? So this definitely represents a function. And let's go ahead and give our domain and range. So the domain is -3, 0, 3, 5, and the range is just 5. Okay? Let's go to number 3. A couple of these might be tricky, so make sure you practice these next ones. Give the domain and range of each relation and then decide if it's a function. So you know what I'm going to do? I'm going to just go through all of these real quick and see if there's a function. They're a function. Right away, I can draw a vertical line there and hit 2 points. This is not a function. Right away, I can see that any vertical line that I ever draw will only hit the graph one time. Yes, this is a function. Right away, you can see this vertical line hits the graph twice, and it's any vertical line. So this is not a function. And this is the graph of a parabola, and as you can see, any vertical line that you draw anywhere will only hit the graph one time. So yes, this is a function. Now let's go back and take care of the domain and range for each one of these. So the domain and range, when you just see points, there's no curve to it, you're just going to list those, -2 and 4. And the range, we have a 3 and a 0, and they don't have to be in any particular order. I'll even show that by putting the 3 first. Now in B, this is a linear function. This is going to go on and on and on and on and on. This is going to go on and on and on. So your domain and your range are both all real numbers. In C, I want you to note that the y values equal 3 and 1, 2, 3, and equal -3, the y values. And the x values equal 5 and -5 and everything in between what I just said, okay? So we do have a limitation. We do have a way we can describe this domain and range. So I will keep the same colors that I did. I'll use this color for the domain. And we see that we can equal -5 and we move to the right and we want everything all the way to +5. Now let's go to the range. And you see we start here at -3 and we want everything going up to 3. So -3 to 3. So I hope that helped. Now for a parabola, note that you do have a highest point. So those y values equal this, which is 1, 2, 3, 4, and everything down. So we want all of these y values for the domain. For the domain, this is going to keep going on and on and on and on and on and on and on. I'm going to exaggerate like that. And so the domain is going to be all real numbers, okay? So these will be all, we will want all of those numbers for the domain. So for our domain, we have all reals. And for our range, we start down here at -infinity. And we go all the way to 4, and we want to include it. So these take a little practice, but please practice these and check your answers. And example 6, our last, that should say number 4. Using function notation. And they give us a function definition for f and g. So first they want f of -3. So what I like to do is I like to write the definition right below or right above what we're wanting. So my x is a -3. So now everywhere there's an x, I'm going to put a -3. Now be careful, because this is -3 squared, and we still have that negative there. -6 times -3 plus 4, that's a -9, plus 18 plus 4, and it looks like this is equal to 13. Now we have f of r, so I'm going to write f of x is equal to -x squared minus 6x plus 4 again, and everywhere there's an x, I'm going to write an r. So f of r is -r squared minus 6r plus 4. And last, we have g of r plus 2. So I'm going to write the definition of g of x. And right below that, I'm going to write what we're looking for. So everywhere there's an x, I'm going to put in r plus 2. So it says 3 times all of x, and our x is r plus 2, and then a plus 1 on the outside. So make sure you're careful with your algebra there, okay? And that's equal to 3r plus 7. And that concludes part 1.